Hello students, in this video lecture we are going to discuss types of functions. So number one, one or injective. A function f from a to b is said to be 1 if different element of a has different image in P. So definition is very simple. Suppose this is a function, this is domain, this is codomain F. So suppose here the elements are 1 to 3 and here A, B, C. If image of 1 is A, 2 is B and 3 is C, here different element has different image. So this type of function is 1. Suppose I give you another example. This is F1, 1, 2, 3, A, B, C, D. So in this case, this function is also 1. Here also different image, different element of A has different image in B. So mathematically, if x1 comma x2 belongs to domain of F, this means A, domain of F, and f of x1 comma f of x2 belongs to range of F, then f of x1 equal f of x2 implies x1 equal x2. So if the function satisfies this condition, then the function is 1. Now I give you some examples. So number 1, f from n to n and fx equal twice x for all x belongs to n. Now we have to check whether this function is 1 or not. Let x1 comma x2 belongs to n. This is domain of the function, such that f of x1 equal f of x2. This implies we can write twice x1 equal twice x2. So this implies x1 equal x2. Here the function satisfies this condition. So we can say this function is 1. Okay, I give you some another examples. So number 2, f from R to R and f of x equal x square plus 2. So let x1 comma x2 belongs to R, such that f of x1 equal x2. This implies x1 square plus 2 equal x2 square plus 2. This implies x1 square equal x2 square. So this implies x1 equal plus minus x2. So here x1 not equal x2. So f is not 1 1. Graphically, if a horizontal line, this means parallel to x-axis, cuts the graph at most once, then the function is 1 1. So I give you some example. Suppose f from r to r and f of x equal x. This is identity function. So the graph is like this. You all already know about this. So if you draw some horizontal line, so suppose like this, then these lines cut the graph exactly at one point. So in this case, the function is 1 1. Therefore 1 1. So I give you another example. This is number 1. Number 2, f from r to r, f of x equal modulus x. Here the graph is like this. So here you can see, if you draw a line, horizontal line in this position, then this line cut the graph at 2 points. So therefore not 1 1. Again I give you another example. F from r to r, f of x equal x cube. So graph of this function is like this. So here all the lines parallel to x-axis cuts the graph exactly at one point. So therefore 1 1. Okay. So our next type of function is many one. So this is number 2. Many one function. A function f from a to b is said to be many one if at least one element of b is the image of more than one element of a. If at least one element of b is the image of more than one element of a. So this means, if this is the function f from a to b, here 1 2 3 a b c, at least one element of b is the image of more than one element of a. Suppose like this, a is the image of more than one element of a. So this type of function is many one. 1 2 3 a b c. Suppose this type. Here the element a is the image of three element 1 2 3. So this type of function is called many one function. So the next one is onto or surjective. A function f from a to b is said to be onto if every element of b is image of some element of a. Every element of b is image of some element of a. That is, range of f is equal codomain of f. So if you see the figure, suppose this is a function f which is from a to b. Here all the elements of b is image of some element of a, and you can see here the range of f is equal to the codomain of f, which is equal b. So this type of function is onto. But in this example, here range is 1 to 3, this set 1 to 3, and here the range is not equal to the codomain of f, so this is not onto. And also you can say this element has no pre-image, so in this case this is not onto. So graphically, if you check whether the function is onto or not, first of all you have to mark the range portion, and then you just compare the range and the codomain. If both are same, then the function is onto. So I explained it with the help of these examples. Suppose fx is equal x, identity function. Here the graph is like this. So if you see, the range is the complete y-axis, and okay, I forgot to write here, this function is from R to R. So the codomain is also real line, this is y-axis. Here the range and the codomain both are same, so this is onto functions. Again I take another example. Suppose fx equal modulus x, which is also from R to R. If you draw the graph, this is like this. So here the range portion is this portion, codomain is the whole y-axis, to complete this line. So here the range and the codomain both are not same, so here this is not onto. Again, if you take fx equal x cube, which is also from R to R. So if you see the graph is like this. So here range and codomain both are same, so this is onto. Okay, I give another example. Suppose f from R to minus 1 comma 1 and fx equal sin x. So you already know the graph of sine function, so this is like this. So this point is 1 and this is minus 1. Here the range portion is this, so range is this, and here the codomain is also minus 1 to 1, so this is onto function. Now we are going to discuss how to check mathematically whether a function is onto or not. Suppose f from a to b, this is our function, and fx equal y. So first of all we express f of x equal y as x equal phi of y. if for every y belongs to b, we have x belongs to a, then f is onto. Otherwise, f is not onto. And you can say it into. Now I give you some example how to check whether a function is onto or not mathematically. So example number 1, suppose f is a function from n to n and f of x equal twice x, where for all x belongs to n. So let y belongs to n codomain be any element. Then we can write y equal f of x. So this implies y equal twice x, f of x equal twice x. So now we have to express x in terms of y. So x equal y by 2. So now we have to check whether for all values of y, x is belongs to n or x does not belongs to n. For all y belongs to n, this is codomain, x does not belongs to n. So you can find it easily by taking some example. Suppose if you take y equal 1, this implies x equal, if you take y equal 1, then x equal 1 by 2, and clearly this does not belongs to n. So f is not onto. Okay, I gave you another example. Suppose this is f from r to r and f of x equal x square. Let y belongs to r, this is codomain, be any element. Then y equal f of x. So this implies y equal x square. So this implies x equal plus minus under root y. So here for all y belongs to r, this is codomain, x does not belongs to r, this is domain. Because if you take some example, suppose if you take y equal minus 2, then x equal plus minus root over minus 2, and which is clearly does not belongs to r. So f is not onto. Into function. Into function. A function f from a to b is said to be into if there exists at least one element of b which is not an image of any element of a. So this means if you take some example, suppose f1 is a b c is 1 2 3 4. Suppose a is related to 2, b is 3, and c is suppose 1. Here the element 4 is the element 4 has no pre-image. In this case the function is into function. I give you another example. This is f2 a b c d 1 2 3. Suppose a is related to 1, b is 1 related to, c is related to 1. In this case the element 2 and 3 has no pre-image. So this type of functions are called into functions. Or you can say here, if you see this is the range, and range is the subset of codomain. Here the range is this. Here also this range is the range is a subset of the codomain. So you can write this range of f is a subset of codomain of f. So if this condition is satisfied, then the function is into function. The last one is number 5. This is bijective function. A function f from a to b is said to be bijective if f is both 1 1 and 1 2. A function f from a to b is said to be bijective if f is both 1 1 and 1 2. So this is the last type of function, which is bijective function. So in this video lecture we have got 5 types of functions. So these functions are 1 1 or injective. The second one is many one, and third one is on 2, and the fourth is into, and the last one is 1 1 and on 2, which is also called bijective function. Here the number 1, number 3 and number 5 are very important. I hope all of you understood. In the next video I will discuss about some problems about 1 1 and on 2 functions. Thank you.